if you have a look at all of these denominators, they're all surds. And surds are irrational, as we mentioned at the beginning of this chapter. So this denominator is root 3, that's root 2, that's root 5, that's 5 root 2. That says 7, but it's meant to be root 7. And that one there is root 6. Now, if I took the number root 3, what can I multiply that root 3 by to make it a rational number? And the only thing I can multiply by to make it rational is actually itself. See, now root 3 times root 3 is 3, and 3 is rational. So what we're in fact trying to do in these questions, we're trying to take a denominator that's irrational and make it rational. So what I might do is let me rewrite the question. That's the question. And as I just mentioned, you need to multiply that root 3 by itself so that your denominator can be rational. But you can't just multiply the denominator by root 3 without doing the same thing to the top. Okay? All right. Okay. So what you do is you take the question, which is 1 on root 3, and you times it by root 3 on root 3. So now the top becomes root 3, and the bottom becomes 3. And you can see you started off with a denominator that was irrational, and now you've ended up with a denominator that's rational. So let me do that all over again, just so we've got it nice and clear. Okay, we've got the question, which is 1 on root 3, and we multiply that by root 3 on root 3, and now that becomes root 3 over 3. Okay, so really what you've done here, if you think about it, you've taken 1 on root 3 as the question, which has an irrational denominator, and you've rewritten it as root 3 on 3. So if you put this into the calculator and put this into the calculator, you should get the same answer. Okay. Right, moving along to question 2, you've got 6 over root 2 times the top and the bottom by root 2. And you're done. So in this one, we've got 3 root 2 is the answer. There's no denominator. Well, it's like having a 1 there, which is rational. Again, if you type 6 over root 2 into the calculator and get your answer, and you type 3 root 2 into the calculator and get your answer, I expect them to be exactly the same. If you think about it, all you're really doing in these questions, see, you're timesing that by root 2, and because you times that by root 2, you must times the top by root 2. But really, this is just 1. Okay? Root 2 on root 2 is just 1. So that's why when you take the question and you end up with this answer, all you've really done is taken the question and multiplied it by 1, and you've made it look different. That's all you've done. It's no different to taking a fraction. Let's say you've got 3 over 4 as the fraction, and you multiply this by 2 and this by 2, and you get 6 on 8. Okay? So 3 on 4 is equivalent to 6 on 8. They're exactly the same. They just look different. Okay? Same concept. Let's have a look here now. So we're going to times the bottom by root 5 and the top by root 5. So you're going to end up getting root 15 over 5. And that's now complete. The next one, so you got 6 over 5 root 2. A lot of students get this wrong. Well, they end up with the right answer, but they approach it wrong. When you've got 6 over 5 root 2, to make this denominator rational, all you have to multiply is by root 2. Because 5 root 2 times root 2 is 10. Okay? So that's rational, which is perfect. Look, 5 root 2 times root 2 is 5 times 2, which is 10, and that's rational. So you multiply your denominator by root 2, and you multiply your numerator by root 2. So you end up getting 6 root 2 over 10, which you must simplify. Divide that by 2 and get 3. Divide that by 2 and get 5. 3 root 2 all over 5. Right, this next one you need to be very careful. You need to be very careful. So, your denominator is root 7. And what do you multiply root 7 by to get it, to make it rational? You times it by itself, root 7. So what you're going to do here, you're going to take the question and you're going to multiply the top by root 7 and the bottom by root 7. Just be careful here with the expansion. So that's going to be root 7 times root 3 plus 1. And down the bottom, you're just going to end up with 7. Okay, I'd be tempted here to expand the top. And the reason I say that is sometimes when you expand the top, you can simplify more. In this case, you couldn't, but that's fine. Question 6. So you've got 2 root 3 over root 6. So you multiply the top by root 6 and the bottom by root 6. So now the top becomes 2 root 18 and the bottom is 6. Now, like I've been mentioning throughout the chapter, you can't stop here because the root 18 can still be simplified. Okay. And so let's have a look at that. So root 18 is root 9 times root 2, which is 3 root 2. So really here, you're going to have 2 times 3 root 2. So instead of the 18, I've replaced it with 3 root 2 over 6, which becomes 6 root 2 over 6, which simplifies to root 2. Okay, so that's the first part of rationalizing the denominator. And if you have a look at all 6 questions on this page, the denominators were just basically 1 square root. Okay, where the next section we're going to go on to, your denominators are not only irrational because your denominators are surds, but if you have a look, there's a minus in between these two. There's a plus in between these two. There's a plus in between these two. So these are done a little bit differently.